this one, I'm going to do my chart. And I hope you've done the derivatives to see what's happening. Here, values for n, derivatives. And then, since I'm working centered at 0, the derivative at 0. So when n is 0, it's just f of x is sine x. What is the sine of 0? 0. When n is 1, the derivative of sine is cosine. So f prime at 0 is cosine 0, and that is 1. When n is 2, f double prime of x is negative sine x. So f double prime at 0 is negative sine 0, and that's 0. When n is 3, f triple prime of x is negative cosine x. So f triple prime at 0 is negative cosine 0, that's negative 1. When n is 4, what happens? It starts over. Because the fourth derivative, the derivative of negative cosine x is positive sine x. So this one ends up in this cycle. So I can write out a few terms and kind of see what's happening. And we're centered at 0, so it's a Maclaurin series. And I'm going to end up with this. F of x is sine x. So written as a series, I would say, okay, f prime at 0, no, the 0th derivative at 0 is 0. 0 over 0 factorial times x to the 0 power. What does that equal? 0. There's one where your constant term is 0. Plus, then, the first derivative at 0 is 1 over 1 factorial times x to the first. Plus, the second derivative is 0. 0 over 2 factorial times x squared. The next derivative is negative 1. I'll write plus negative 1. You could write minus 1 over 3 factorial times x cubed. The fourth term, I'm starting back up here at the top, 0 over 4, I guess that's the fifth term, isn't it? X to the fourth. Then the next term, plus 1 over 5 factorial, x to the fifth. Then plus 0 over 6 factorial, x to the sixth. Plus negative 1 over 7 factorial, x to the seventh. There's the Taylor series. It keeps going. Now, what we'll do is we will collapse this. Let's take out all the terms that are 0. So it would be this. This is 0. This would be x to the first. This is 0. Minus 1 over 3 factorial x cubed. This is 0. So plus 1 over 5 factorial x to the fifth. Minus 1 over 7 factorial x to the seventh. And if I want to write this in summation notation, you can see this in the book. I'm actually going to start it at 0. It starts at 0, goes to infinity. I got to think further down here. This is n equals 0. This is n equals 1. See, I'm collapsing out all those terms that were 0. This is n equals 3. Do I want to start at 0? I think I want to start at 1. So I'm looking 1 over 2. No, I'm starting at 0, aren't I? 2n plus 1 factorial When n is 0, that's 1. When n is 1, that's 3. I'm right here. When n is 2, it's 5. Here it is. Here's the power series, the Taylor series for sine x. They do another problem where they do cosine x. Well, you know what they do? They just say, let's do the derivative of sine. Yes?
What about the negative?
Oh, I forgot about the negative. Thank you. Is that why your hand was up?
No.
Okay. -1. Let's see. The first term is positive. The next one's -1 to the n. I think we'll take care of that. Thank you for that question.
I wrote the power series, or I wrote the series in sine of pi